one of the important things that we feel like we should discuss with you today is where to go next. What do we do next? Should you find interest enough in this project and the prototype to carry it on into a next iteration? Well, obviously, some of this is going to sound like no-brainers, but I want to cover a few things for you anyway. It would be ideal to try to test access to virtual machines over the internet. As we mentioned in the scope, we decided to keep our prototype completely isolated from the campus network, just in case there were any problems. We didn't want to slow down or impact the network at all. But since we've gotten some indication that it is working and it isn't using up all of those resources, it might be an ideal thing to try. To facilitate the migration to a live server environment, we recommend upgrading all the ESXi servers to a gigabit speed NICs, possibly even dual or quad core, for a dedicated vMotion porting to alleviate network congestion. It would also be preferable to provide a high-speed iSCSI storage replacement for the NFS, which is the network file system. It's how vCenter and the ESXi servers all access the storage where the virtual machines are, because when you have a lot of virtual machines, they can take up a lot of space very quickly. On the prototype, it is mentioned before, and during when Lester was saying he couldn't click the clone template. Well, right now it takes about 30 minutes to clone a virtual machine, and we believe that might be alleviated if the system were put on an actual server. Right now, it's just a regular desktop like every single other one in this room. And we don't know for sure if that's affecting how fast it takes, but yeah, regardless, the process should be completed much more quickly than it currently is. Also, it would be preferable to have in place some sort of a redundancy scheme that allows for errors. Should a backup of virtual machine, say, be scheduled for a certain time, it would be preferable to inform everyone, say, via Blackboard, that the system will go down for a certain amount of time and when. That way that they can schedule doing their lab work in advance around that. Automation. First of all, it would be ideal because of the fact that these are running inside classrooms whenever there's a class. If a class comes in, they're going to shut down all the ESXi servers. So some sort of an automation that would start and suspend virtual machines or shut down the system, shut down inactive virtual machines, maybe start them up in another class would be ideal. Another thing that's interesting is that every time, say, DRS or high availability kicks in, eventually this virtual machine could wind up on that ESXi server. Well, whenever Virtual Center starts, it's supposed to start on a particular star ESXi server. So if you can automate shutting down all of the virtual machines, shutting down vCenter, restarting vCenter, and connecting everything back together, that'll put everything in a clean state, a gold state, where every machine is where it's supposed to be. A new thing that just got released, we haven't had, and it's within the past couple of weeks, is VMware introduced vSphere. Essentially, that's the next phase of infrastructure. It has new components. It has the same components, but a few minor tweaks and upgrades. And it's kind of idealizing how the components work with each other inside infrastructure. But it has some capabilities that Infrastructure 3.0, which is what we're using right now, does not have. For example, vSphere, you can clone Vista and Server 2008. You can't in Infrastructure 3.0. An interesting new feature that vSphere has now is called fault tolerance. Now, what that is let's say I have this machine and this machine, and they're both ESXi servers. When a student starts a virtual machine, it loads in this one, but at the same time it creates a clone of the virtual machine in the second one. they're run in lockstep, in tandem. And what should happen is if this encounters any kind of hardware error or shutdown, then the student's connection automatically goes to the clone with zero downtime. And then the clone actually becomes the main server, and vSphere automatically fault tolerance, automatically creates another clone running on another ESXi server. So it's basically, it's based on high availability and vMotion, but it's a new functionality that they have come up with for vSphere. And another new feature to vSphere is vStorage, which handles the way virtual machines are stored differently than previous versions of infrastructure. In virtual infrastructure, each virtual machine folder is allocated a specific space when you create it. This could be 10 gigabytes or more. Now, what happens is thin provisioning allows the unused portions of the disk space for each virtual machine folder to be seen as free space by the system, so that you can actually you can use that storage. In other words, it doesn't use it up until it needs, and then it grows the virtual machines as more information is written, say if a student installs software. But the problem is in older versions of infrastructure, ESXi wouldn't see that the actual physical storage would be almost used up, say on a storage network. So it would continually try to keep expanding virtual machines and growing them, even though there might not be physical space to do so. Well, they've fixed that with vSphere. They've made it so that the components talk to each other. In ESXi, it's continuously monitoring it. So ESXi knows, I'm almost out of space, so I can't grow this anymore. That allows you to do something to either add more storage to the network or what have you. Also, linked cloning is interesting. And it's like cloning technology, but what it does is it reduces the amount of storage needed for a multitude of clones by eliminating the duplicate storage of data. In other words, you have 50, say, Vista virtual machines. Well, when you install them, a lot of that data is exactly the same. So it creates one hard copy of all the same data. And then for each change that's made to each individual virtual machine, it saves that. But it doesn't save the same data 50 times. So that could help you save on storage space. It was recommended to us by an expert that the preferred method of user access to virtual machines is with remote desktop. This is because of the significantly faster connection, and also because VI client is really for administrators primarily. A normal user that just wants to start a virtual machine might be confused by all of the options provided, and they don't need to see all that stuff anyway, whether they can access it or not. But there are a few gotchas with remote desktop. Unfortunately, if you're using remote desktop, all the virtual machines have to be started and running in order for you to access it, because you'd have to put in the IP address or URL of the specific virtual machine into the name bar when you're trying to access it. Now, this could be alleviated through possibly automation. Virtual infrastructure has a lot of automation options. You can set schedules, or possibly even you could write a script to do so. But that's something that would be interesting to look into as an option in the future. Another alternative, which we haven't really had the chance to test out, is possibly using web access directly, like Lester showed you very early on in the demonstration, instead of remote desktop. That's a possibility, but we don't know how it performs, if it performs quicker than remote desktop or if it's that viable. But it is an alternative to, say, using web access to download VI client and then running VI client and waiting for the VI client that's slow and it has all the administrative